Hey guys, Mr. Larson. Today we're going to talk about 2.3, which is synthetic division. A lot of this is a review. We're going to not only go over the mechanics of how to do synthetic division, but also talk about a couple different vocab words and how those relate to using synthetic division, and then talk about a couple different applications, things that you can do with synthetic division. Okay. So here's our learning targets at the top. And then this is kind of like the setup in order for synthetic division to be used. So your divisor needs to be a linear factor. So if we look at example 1, the value that we're dividing by, in this case, they're all going to be binomials. Those are going to be linear factor with a coefficient of 1. So x plus a constant or x minus a constant. Okay. The polynomial needs to be written in standard form. So this has to be standard form, and the reason is that we need those coefficients listed in order that we see them once it's in standard form. Third one, we must have a coefficient for every power of x. That means that once we start, like for example number 2, I start with an x to the third. That means I need to have an x squared. I need to have an x term, which is currently missing, and then you need a constant. Okay, so we'll talk about what to do with the missing x term. And then the degree of your answer is always going to be one less than the original polynomial. So for number 1, when I divide this 3x cubed polynomial by x minus 4, I'm going to be left with something x squared, right? I like to call it drilling down. I'm drilling down by 1. So it goes from an x cubed, and then once we divide it, it gets down to x squared. And think about it, if I just take this first 3x cubed over x, when you divide by x, it's going to be 1 less on the top, right? So that's kind of that same idea. All right, so let's go ahead and dive in. So synthetic division, it's a little goofy, but hopefully you guys remember a little bit from last year. I'm going to list my coefficients and constants in the order I see them. So 3, negative 13, 6, negative 8. And then if you're dividing by x minus 4, that's the factor we divide by, but we want to put the 0 in this little box up here. So x minus 4 equals 0. That means x equals 4 is the 0 or the root or the solution, whatever you want to use. And that's the number that's going to go in there. So you can think of it as the opposite. Excuse me. And that should work for you. Okay. Hopefully you can draw a straight horizontal line. I failed. But the first thing we're going to do is add down. There's nothing below the 3, so really you're just dropping the 3. But always think add down. So I drop 3. And I'm going to work in a pattern like this. Okay, next I'll find this number, then I'll find this number. Then here, then here. Okay, then here, then here. All right, so they're not all zeros. Those are circles for where the numbers go. So the way that you get the numbers in the row underneath the coefficients is you want to multiply the number that you just dropped. So in this case, the 3 times the number in the box. So 4 times 3 gets me 12. So I multiply to get that number. And then we add down. So negative 13 plus 12 is negative 1. Once I get the number down here, the negative 1, I want to multiply it by the number in the box. So that gives me negative 4. And then I add down. So 6 plus negative 4, same as 6 minus 4, that gives me 2. Now I do 2 times the number in the box. 2 times 4 is 8. Now I add down. So we said that the result is going to be 1 degree less than what we started with. So this 3 becomes my coefficient for x squared, right? I started with x cubed. Now I have x squared. Now I have x. 2 is my constant. There's no x attached to that. And then this last, so this is your constant. And then this last one is your remainder. Okay, so here's how we write this. 3x squared minus x plus 2, and I don't have a remainder. Okay, there was no remainder. Okay, let's do this one. So we said that there's no x term. If you're missing a term, put it in with a coefficient of 0. That's how it ends up dropping out, right? Like there is no x term. Well, it must have been 0x, okay? The synthetic division will not work unless every coefficient is accounted for after the one that you start with. So 0, -8, I'm dividing by x plus 2, so -2. -2 is going to be the number in the box. So I add down, multiply, I add down, multiply by -2, add down, multiply by -2, add down. Okay, so I started with an x cubed. This will be x squared. This will be x. This is my constant. This is my remainder. Okay, so I like this one because we get an example with a remainder. So we say that this equals 4x squared minus x plus 2, and then a remainder of -12. So we subtract 12 over what we were dividing by. Okay. Okay. You don't have to remember the name, the factor theorem, but here's how this works. For any polynomial f of x, if you do synthetic division and you divide by x minus k and you get a remainder of 0, kind of like we did on number 1, what that means is x minus k is a factor, okay? And if x minus k is the factor, that means k is your 0. And another word for 0 is the x-coordinate of your x-intercept or solution or a root, okay? So if x equals -3 is a solution, that means that x plus 3 must have been the factor. Because when we set x plus 3 equal to 0, subtract 3, we get x equals -3. So you'll have problems that are worded like 3a, where it says use synthetic division to show that x equals -3 is a solution of this polynomial here. So keep in mind, I already have the 0 or the supposed 0 here. That's not the factor, so -3 is the number that goes in the box. So notice the difference between showing that x equals -3 is a factor and dividing by x plus 2. That's worded differently, right? Here we had to set equal to 0 and solve for x to get x equals -2, the number in the box. Now they're already telling us the number in the box. So 1, 3, -4, -12. Add down, multiply by -3. Add down, multiply by -3, add down, multiply by -3, add down. Okay, so when you get a 0 as a remainder, I like to put a little check mark there. It means there's no remainder, and whatever you divided by, x plus 3, is a factor. So let's see. This proves x plus 3 is a factor. Okay, x equals -3 is a 0. That's kind of a different way to say the same thing. And then it says use the result from part A to completely factor the polynomial and state all real zeros. Well, what we mean by that is what's left over? Well, I'm left over with x squared. I don't have an x term, but I have a -4, right? So that means that my original polynomial could be written as, let's see, I know x plus 3 was a factor, and then the leftover part is x squared minus 4. So I can set that equal to 0. Let's pick that workup down here. So x plus 3, I can factor x squared minus 4 as x plus 2, x minus 2. So that's the complete factored polynomial. And then my zeros would be x equals -3, which I already found out, -2, and +2. Okay, so maybe we'll say fully factored is f of x equals x plus 3, x plus 2, x minus 2. Okay. Okay, remainder theorem. So here's how this works. If I want to find, let's see, if we want to plug in 4 for x into a polynomial here, what that really means is we're doing f of 4 equals, and then I would do 3 times 4 to the third minus 13 times 4 squared plus 6 times 4 minus 8. Now you're going to be expected to do a problem like this with no calculator. I don't know if I could do that right now. 4 to the third, I think that's 64 times 3. This is going to take me a little while to do that. Okay. Another way to do this, especially if it's non-calculator, is, okay, what are you plugging in? Let's put that in the box and then list our coefficients. We're going to do synthetic division. This is a application of synthetic division. Let's run this through. So add down, multiply, add down, multiply, add down, multiply, add down. Okay, so the remainder theorem tells us that whatever number you're putting in the box, if you plugged that in for x, your output would be the remainder theorem. Okay, so what this is telling us is f of 4 is equal to 0. Okay, so you guys can go ahead and check that with a calculator, plug in 4 for all the x's, but what you're going to find is f of 4 is equal to 0. Okay, next. Actually, you know what? I'm going to let you guys do number 2. No reason for me to do that. Okay, so you can check the key to figure out what number 2 is. And then the bottom is meant to be practice for you guys. And I think all these are pretty manageable. 3 would be a little tricky, but I think you guys can think of that. 2 is the one that I want to show you guys. So is x minus 1 a factor of f of x equals x to the 16th minus 4x to the 15th plus 3? Feel free to try this. You can pause and then come and see the answer worked out. Okay, or you can see me work it out. So is it a factor? Well, we want to run synthetic division. So this tells us that x equals 1. 1 is the number we're going to put in the box. And then let's list our coefficients. I have 1, I have negative 4. Oh, wow. And then I'm going to have x to the 14th is 0, x to the 13th, x to the 12th, x to the 11th. Wow, that's going to take a while. Let me actually just start this synthetic division before I continue writing those zeros, because I'm going to run out of space here. But let's add down. Now we multiply. Then we add down. Multiply. Add down. Multiply. Add down. Okay, you guys see a pattern here, right? I think this is going to continue. So for all these zeros, that's going to continue. Then my constant is a 3, right? So I'm going to continue having negative 3. I'm going to continue having negative 3. And then I do 1 times negative 3 is negative 3. Add down, and that's going to give me 0 at the end. Okay? So, yes, you could list, what, 14 zeros, right, for x to the 14th all the way down to x to the 1st. Or you can kind of use some logic and notice that it's the exact same operation every single time. It's going to keep generating a negative 3 there. By the time it gets to that 3 at the end, they'll cancel each other out and give you 0. So now let's answer that question. Is x minus 1 a factor? Well, we said if the remainder is 0, then it is a factor. So yes, x minus 1 is a factor. All right, guys, that wraps this up. Please go check the key for the, 5 or 6 problems that we didn't get to. And thanks for watching.